Hello guys, today I am going to talk to you about multivariable calculus. First of all, let me briefly explain what we are going to do today. We will learn identifying functions of two or more independent variables, evaluate functions of several variables, and use three-dimensional coordinate systems. Functions with two or more independent variables are called multivariate functions. A function that depends on two independent variables is called a function of two independent variables. It's expressed as z equal to f x y. The variables x and y are independent variables and z is a dependent variable. A function that depends on three independent variables is called a function of three independent variables. It's expressed as w equal to x, y, and z. We learned the two variables functions which express as z equal to f x, y. So the set of all ordered pairs of permissible values of x and y is the domain of the function, and set of all corresponding values is the range of the function. Unless otherwise stated, we will assume that the domain of a function specified by an equation of the form z equal to xy is a set of all ordered pairs of real numbers, and such that f x y is also a real number. It should be noted, however, that certain conditions in the practical problems often lead to further restrictions of the domain of a function. So let's solve a problem. For the cost function is cxy equal to 100 plus 60x plus 100y. So we are going to find c 5, 10. So it is pretty simple because we are going to put 5 when we see x and we are going to put 10 when we see y. So as I said before, we put 5 when we see x and put 10 when we see y. And when we do like that, the result will be 2,250. So the second question is very simple too. We are going to put 2 when we see x, 3 when we see y, and 4 when we see z. By the way, it is the function of three independent variables, and the first one is a function of two independent variables. So when we put these numbers into the function, our answer will be 98. So there are a number of concepts that we are familiar with, can be considered as functions of two or more variables. So we are seeing a rectangle and a rectangle box, right? So we are going to find area of rectangle L times W, which is we can be expressed as a function L equal to L times W. And the volume of a rectangle box is pretty simple too. We are going to express as function H equal to L times W times H. So we are going to learn Cobb-Douglas production function, which is economists mostly use to describe number of units produced from units f x y. Produced from the utilization of x units of labor and y units of capital. This function is the form of x, y, fxy equal to k times x prime m times y prime n. So we should think like that k, m, and n are positive constants with m plus n equal to 1. So if the m is 0.5, the n should be 0.52 because it should be equal to 1, right? So the Cobb-Douglas production function. The production of an electronics firm is given approximately by the function f(xy) equal to 5x prime 0.3 times y y prime 0.7. With the utilization of x units of labor and y units of capital. If the company uses 5,000 units of labor and 2,000 units of capital, how many units of electrons will be produced? Now, we are going to use 0.3 and 0.7, right? We learned that m plus n should be 1, right? We can see right there. Anyway, we see x equal to labor equal to 5,000, and we also see y equal to capital equal to 2,000. So what we are going to do, we are going to put 5,000 when we see x, and we are going to put 2,000 when we see y. So as I said before, the answer will be 13,164. So now we are going to learn three-dimensional coordinates. A three-dimensional coordinate system is formed by three mutually perpendicular number lines intersecting at their origins. In such a system, every ordered tripled number of numbers x, y, z can be associated with a unique point, and conversely. We use the plan such as the one to the right to display this system on a plane. So we are going to solve this problem. Locate 3, minus 1, 2 on the three-dimensional coordinate system. Now we should think like in the 3 dimensions. So we are going to draw into this coordinate system. Like we are going to 1, 2, 3 and draw the x, and then we are going to draw the y and z. So you can see the point in the middle, right? This point indicates the point where x, y, and z intersect. In this question, it has already given us the values of x, y, and z. And when we write these values in the three-dimensional coordinate system, we find the answer in this way. So consider the graph of x, z equal to x squared plus y squared, and if we let x equal to 0, the equation becomes z equal to y squared, which we know as the standard parabola in the yz plane. And if we let y equal to 0, the equation becomes z equal to x squared, which we know as the standard parabola in the xz plane. But the graph of this equation, z equal to x squared plus y squared, is a parabola rotated about the z-axis. This surface is called a paraboloid, which is the hardest part. So some graphing calculators have the ability to graph three variable functions. You see the three variable functions right there in the photo. So, however, many graphing calculators only have the ability to graph two variable functions. With these calculators, we can graph cross-sections by these planes parallel to xz plane or yz plane to gain insight into the graph of the three variable function. So we are seeing the function of z equal to x squared, right? Because y is equal to 0, and this part we are seeing the graph of z equal to x squared plus 4, because the y is equal to 2, and when we put these two the z equal to x squared plus y squared, the graph will be z equal to x squared plus 4. So graphing surface in the yz plane is actually the same as the previous graphing surface in the xz plane, but the some things are different. For example, here is the cross section of z equal to x squared plus y squared in the plane x equal to 0, and this is a graph of z equal to y squared because x equal to 0, and when we put 0 when we see x, the graph will be z equal to y square, and the graph is right there. Graph's photo is right there. And when we put 2, when we see y, the graph of the function will be z equal to 4 plus y square. So we defined functions of 2 or more independent variables. We saw several examples of these functions, including the Cobb-Douglas production function. We defined and used a 3-dimensional coordinate system. So thank you for listening me. Now let's look at the questions. The first question is for the cost function cxy equal to 2000 plus 10x plus 100y. Now we are going to find c3, 5. Now what we are going to do, we are going to put 3 when we see x, then we are going to put 5 when we see y. And when we do like that, our answer will be 2530. And the second question is for fxyz equal to x squared plus 5xy plus 10xz plus 4yz plus x squared. Now we are going to find f1, 3, and 5. So it is same as the previous question. We are going to put when we see x, put 3 when we see y, put 5 when we see z. So when we do like that, our answer will be 151. So the third question is for the cost function cxy equal to this equation, and we are going to find c2 and 8. So we are going to put 2 when we see x, and we are going to put 8 when we see y, and the answer will be 2440. So the fourth question is fxyz equal to this equation, and we are going to find f4, 3, and 2. So we are going to put 4 when we see x, and we are going to put 3 when we see y, and we are going to put 2 when we see z, and the answer will be 60. So the other question is, the production of an electronics firm is given approximately by the function fxy equal to this, and with the equal utilization of x units of labor and y units of capital. If the company uses 100 units of labor and 225 units of capital, how many units of electrons will be produced? Now, what we are going to do is we are going to put 100 when we see x, which is labor, and we are going to put 225 when we see y, which is capital, and the answer will be 600. Now we are going to locate 2, 3, 4 on the 3-dimensional coordinate system. Now we are going to draw these points and intersect onto middle points, and the answer will be like that. So the other question is same as the previous question, but the numbers are different. So we are going to locate -3, 2, and -6 on the 3-dimensional coordinate system. So first of all, we are going to draw these points, and after that we are going to unify the points, and where they intersect, the intersect will be our answer. This black point will be our answer, which is -3, 2, and -6. So the next question, the production of an electronics firm is given approximately by the function fxy equal to this equation, and with the utilization of x units of labor and y units of capital. If the company uses 10,000 units of labor and 400 units of capital, how many units of electrons will be produced? It's pretty easy actually. We are going to put 10,000 when we see x, and we are going to put 400 from CY. So the answer will be 14,000. And the other question is, here is the cross section of z equal to x square plus y square in the plane y equal to 3. So the graph will be z equal to x square plus 9 because we are going to put when c y 2, 3 and simply the graph will be z equal to x square plus 9. So this is the last question. Here is the cross section of z equal to x square plus y square in the plane y equal to 5. This is a graph of z what? The solution will be z equal to 25 plus y square because we should write 5 from c x. So that is all. Thank you for listening me.